So I'm calling this section Section A. I kind of call it Section A because technically this section isn't in the book. And Section 4, which would have been the next number in this chapter, is not this section at all. So I didn't want to call it 4 and confuse you guys. So I called it 10.A. It's just that it's not in the book. But we do need to know it, and you will use it next year. So the distance formula is basically just how do you find the distance between 2 points. So we have our coordinate axes here, and we have 2 points. There's point A and point B. If we drew a little line segment between them, we could find the length of this line, and the length of that line would be the distance from A to B. So the distance between any 2 points can be found using the Pythagorean theorem. So if I were to draw little segments here, what did I just make? What kind of triangle? A right triangle. And if I have a right triangle, what can I use? I can use the Pythagorean theorem. That's right. So we have a right triangle sitting right here. Now, based on what we see, if we knew the length of this segment right here, and if we knew the length of this segment right here, then we could use the Pythagorean theorem to find the length of this segment right here, the one that we're actually looking for. So, how could I find the length of this segment right here? Yeah, you could count how far did we go from here to here. And however far we went, that would be the length of this segment. And we could do the exact same thing here. Count from here over to here. How far did we go? That's the length of this segment. And then you just square that, and then basically you're using the Pythagorean theorem. Square this, add it to the square of this, and then wind up taking the square root of both sides. Okay? So if we have 2 numbers here, like if I have, let me just make up numbers here. Ignore the numbers on the side. I'm just going to make up a couple numbers. So let's go 1, 5 here, and I'm trying to come up with numbers that are kind of easy. How about 6, 1 here? So if that's 1, 5, and this is 6, 1, what are the coordinates right there? No. So the x-coordinate would have to be 1, because it's directly below there. And the y-coordinate would also have to be 1. Okay? So now if we know that, then we can count. We're sitting here at 1. We got to go all the way up to 5. How far do we go? 4 units. All right? Now how could I figure out that 4 without sitting here and counting lines? Yeah, do the 5 minus the 1. How could I figure out this distance right here? How far is that? It's 5. We can count 1, 2, 3, 4, 5. Or, that's right, we can take the 6 minus the 1. Okay? So this length winds up being how much? 5. Now to do the Pythagorean theorem, you're going to take this and do what to it? Square it. You're going to take this and square it. And then what will you do with those 2 numbers? Add them together. So if I take this number, that's my 4 right there. This is how I got it. The 5 minus 1. I'm going to square that. The 6 minus 1 is 5. That's how I got the 5. So 5 squared, 6 minus 1 squared. And then we said I'm going to do what to them? Add them together. Yeah, now that would give me c squared, but I don't want c squared. I actually just want c. So how do I get just c from c squared? Square root. So if this gives me c squared, then c will be the square root of all of that stuff. That is the distance formula. All the distance formula is, sitting right here, all it is the Pythagorean theorem. That's it. You already know how to do the Pythagorean theorem. It looks different because it's using more formal notation here. What is x2 minus x1? Well, up here, to get that, we did, this is x2, and we subtracted x1. This would be y2, and this would be y1. So your x2 minus x1 gives you this guy right here. You square it just like we did up here. The y2 minus y1 gives you this guy right here. Square it, and you got it. What? You will not need a ruler. You actually don't even need a figure. All you need is two ordered pairs, and you can use the distance formula. You won't even have to look at it on a graph anymore. We're going to graph them just so that we can see that it does actually use the Pythagorean theorem, but you don't need it. You can do just the math. So this is a formula I expect you to memorize. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All it is the Pythagorean theorem. So if you can keep that in mind, it makes the distance formula a little less scary. So find the distance between the points 5, 3 and 1, negative 2. So what I want to do first is put those on this grid. 5, 3, 1, 2, 3, 4, 5, 1, 2, 3 is right there. And then 1, negative 2. So 1 and then negative 2 is right there. So it says find the distance between the points. That means we're trying to find how far is it from here to here. That's all we got to do. It's always going to be a positive result. We could draw in a little segment here, but basically that's it, okay? So let's use the Pythagorean theorem first. If I draw a little line here, and I draw a little line over here, and I draw a little line over here, I've made that right triangle. So this is a right triangle right here. All I need to know is this length and this length. The length. Length is never negative. So how far is it from here to here? 1, 2, 3, 4. How far is it from here to here? 1, 2, 3, 4, 5. Okay, so we're ready for Pythagorean theorem. It is a squared plus b squared equals c squared. So that will be 4 squared plus 5 squared equals c squared. 4 squared is 16 plus 5 squared is 25 equals c squared. So that's 41 equals c squared. And then to get just c, remember you have to get just c. Some of you are forgetting that on your homework. You take the square root of both sides, and now you have c equals the square root of 41. And from what we just learned in the last section, we could leave our answer like that as long as it's simple, in simplified form. Is there a perfect square that goes into 41? No. So that means that this can be our answer now, rather than using a calculator and getting the decimal approximation. If we did that, it'd be like 6.5 or so. 6.4 what? 6.40. Okay, so it would be 6.4 would be our approximate answer. But this is the exact answer, which is really nice. That's what we like. Okay, so let's use the distance formula now instead. I just want to show you that you do get the same thing. So the distance formula is d equals the square root of x2 minus x1 squared plus y2, I almost wrote that in the wrong spot, y2 minus y1 squared. Very similar to the slope. Remember y2 minus y1 over x2 minus x1? You can kind of remember that these two pieces are like that, except now we're squaring them and we're adding them together. So that's another way you can remember the distance formula. Okay, so if this is x1, y1, and this is x2, y2, it's just a matter of plugging stuff in and simplifying it down. D equals square root x2 minus x1. So x2 is 1 minus x1 is 5 squared plus y2, which is negative 2, comma, y1, which is not comma, y2, which is negative 2, minus y1, which is 3 squared. Everything's plugged in. Now we just simplify it down. D equals square root. What's 1 minus 5? Negative 4. What's negative 4 squared? 16. Plus, what's negative 2 minus 3? Negative 2 minus 3 is negative 5. Squared and you get 25. Look familiar? We have 16 plus 25 here, 16 plus 25 here, so D equals the square root of 41. Exact same answer. So really, the distance formula really is just using the Pythagorean theorem without having to draw the sketch and count lines. It makes it easier. So that's why we need to know the distance formula. So for this one, what I want you to do is plot the points. We'll take a look at it, maybe guess to see how long that segment is, and then we'll use the distance formula to find out how long it actually is. So 4, 2 is where? Over 4 to the right, up 2. And then negative 3, negative 1, how would I do that one? Left 3, down 1. Okay, so before we do the distance formula, let's try to guess how long is that segment. You think it's 7? Okay, I'll mark that one down. Anybody else have a guess? Pick one. 9? 8? Okay, 7, 8, 9, somewhere in there.
6.5.
Well, is it going to be longer than this length right here? Yeah. 1, 2, 3, 4, 5, 6, 7. So it has to be longer than 7. Otherwise, it's not a hypotenuse of a right triangle. Okay. So it must be at least 7. Probably not much more, though, than if I did 7 plus 3, that would be 10. It can't be longer than those two sides added together. So it's got to be between 7 and 10 somewhere. Probably like around 8. That's my guess. I don't actually know. So let's do the distance formula. What do I write? Okay, x2 minus x1. Whoa, wait. Squared. Don't forget to square it. Okay. All right, now what do we do? Okay, plug everything in. So we have square root, and what am I going to write? So let's stop. Let's call this x1, y1, and that makes this? Okay, that's just for in case you get lost. Now you're not going to mix them up. You're not going to get confused. So negative 3. Okay. All right. Yeah, don't forget those squares. That's kind of one of the most common mistakes is people leave off the squares. Okay, d equals square root. What do I get inside these parentheses here? Somebody else, please. Negative 7 squared. Yep, you're right. I'm just going to write it down, though. Plus, inside the second set of parentheses, what do I get? Negative 3. That's right. Squared. Okay, so now we have d equals square root. What is negative 7 squared? Positive 49 plus 9. And what is 49 plus 9? So we have the square root of 58. Now, we can simplify that square root if it can be simplified. Is there a perfect square that goes into 58? No. 24 doesn't go into 58. It's not a perfect square either. Does 4 go into 58? No. 4 goes into 60, not 58. What about the next perfect square, which is 9? Does 9 go into 58? No. What about 16? 16 times something, maybe? No? 25?
Yes, times 2. Wait,
no. No, that's 50. So that doesn't work. 36? No. 49? No, definitely not. So, can this be simplified? No. So this would be our answer right here. But we wanted to know, in like the actual approximation here, between 7, 8, and 9, we said. Let's get the decimal of that. What do you get? 7.615. Okay. 7.615. If I wanted to round that to the nearest hundredth, what would I write? 7.62. Nearest hundredth is 2 decimal places. So we're looking at the third decimal place. That's a 5, so we're going to round up. 7.62. So it was between 7 and 8. Probably a little closer to 8 than 7. So if you were thinking 7 or 8, that was a pretty good guess. But we can leave our answer now as just the square root of 58. Things get kind of tricky when you're working with the negative numbers. Just remember, if you have that minus sign there, and if the number that you have to write down is negative, then it's minus minus, which turns plus. So the distance will be the square root of, maybe we can do this time without writing down x1, x2, and so on. So what should I write? 5 minus, and then x1 is negative 7. I already have the negative, so that turns plus. 5 plus 7 squared plus, parentheses, what? 4, and then minus negative 2. 4 minus negative 2 becomes 4 plus 2 squared. All right, D equals square root. 5 plus 7 is 12, squared is 144. Plus 4 plus 2 is 6, squared is 36. So we have 144 plus 36. D equals the square root of 180. Now, we need to make sure that our square root is simplified, which means that there are no perfect squares that go into 180. What's that? 36 and 5. You want your biggest perfect square that goes into 180. If you can't think of those perfect squares, just do this. Off to the side, 180, and just start doing the prime factorization. 2 and 90, 2 and 45, 3 and 15, 3 and 5. And you can do those in any order. Then circle your pairs. We have a pair of 2s, we have a pair of 3s. If we multiply all that together, 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36, 36 times 5 is how I'm going to split this up. So this becomes D equals the square root of 36 times 5. The square root of 36 is 6. And I can't take the square root of 5, so I leave it. This simplifies to 6 square root 5. 6 root 5. That's the answer. I don't need the grid, so let's just go straight to the distance formula. What do we do? Okay.
Parentheses squared.
Yep.
Plus, parentheses, minus 7, plus 6.
Minus 6.
Minus 6.
So it's always minus, and then you go to the number. The number is positive 6, so you write negative 7 minus 6 squared. Now what? Negative 3 squared is positive 9. Negative 7 minus 6 is negative 13. Squared is 169. So plus 169, 178. All right, now we have to simplify that. If it can simplify, does it? No, it does not simplify. So that's the answer, the square root of 178. If you were asked to round your answer to the nearest hundredth, you could then plug in the square root of 178, hit enter on your calculator, and it'll give you an answer. What would the answer be? What? 13.3? Okay. So that's how you would do that. What is the numbers what through what on the assignment? 1 through 16 all. Okay. That's it for the distance formula. You're on the worksheet in your packet. 1 through 16 all. Shouldn't take very long at all.